Analyzing Missing Migrants Part 6, Brushing. The time has finally come to add this sort of brushing interaction to our multiple views. I'll start by forking this multiple views cleanup example. The main idea here is to add brushing to this bottom view and then use that brush to filter the data that's shown on the map. The D3 brush package provides utilities for brushing. The API reference is good to have, but I feel like we need a concrete example. Here's a good concrete example of Brush and Zoom by Mike Bostock. We can analyze this code to see how to use d3.brush. This example uses d3.brushx because the brush only varies in the x direction. Over in our newly forked program, which I'll rename to multiple views with brushing, we can use that d3.brushx. But where should we put it? I think it needs to go on the date histogram in index.js. This is where I'll put it for now. Along with our other D3 imports, we can import brushx. And then let's go back to that other example, this one, to study how the brush is used. d3.brushx is invoked to create a brush instance, which is stored in a variable called brush. Then the extent of that brush is set up, and an event listener is added for when the brushing gesture ends. This brush variable is then called on a group element. The upshot of this is that we're going to need to have access to the group element that got rendered by React. We can use React to set up that group element, but we're going to have to somehow get access to that raw DOM element and then give the D3 brush access to that raw DOM element. Working in React is kind of like living in the Matrix. On the one hand, you can continue to live in this nice virtual world of JSX. On the other hand, you could expose yourself to the harsh realities of the real world of these raw DOM elements. And that's what we need to do to work with D3 brushes and D3 animations when we get there. But how can we escape from React's world of virtual DOM? What is that pill that we can take that will eject us out of the virtual world? Luckily, React does provide this so-called escape hatch, and it's called React Refs. If you do a Google search for React use ref, you can find the hooks API reference for use ref. React refs, short for references, are what allow us to break free of the virtual DOM world. The useRef hook is what allows us to tap into this feature of React. This documentation shows in a nutshell how to use React refs. useRef returns a mutable ref object whose .current property is initialized to the passed argument, the initial value. The returned object will persist for the full lifetime of the component. What that means is that when you initialize the ref like this in a component, this object will be the same object on each and every render. The thing that could possibly change is the .current value of this ref. Here, the code creates a new ref called input_l, and the initial value of input_l.current will be null. Down here, when rendering this input element, the ref prop is set to be input_l, this ref. When you pass a ref into the ref prop of any JSX element that represents a native DOM element, such as input, or div, or span, or SVG, or SVG group elements, when you do that, after React renders these DOM elements, input_l.current, in this case, will be the actual raw DOM element, in this case an input element. In this particular case, there's this onButtonClick callback being passed as the onClick event handler to a button. When the user clicks on this button, this function here is invoked. And because this happens after this DOM element has been rendered, input_l.current is the actual input DOM element, which can then be focused. That's React refs in a nutshell. Now let's use React refs to make our D3 brush happen. Back in our date histogram index.js, let's import useRef from React. In our component, we can set up a ref. I'll say const brush ref equals useRef. Now, in our JSX, we can add a new element, an SVG group element that can contain this brush. Since this element needs to come in front of everything else so that the interaction surface is not obscured by anything, it needs to come after all of these other elements. But it should still be within this inner group element. So down at the bottom, but before that closing group element tag, I'll set up a new group element, and I'll set the ref of this group element to be brush ref. Now we're in a position to access this raw group element, the DOM element itself, which we need to work with the D3 brush. To do that, we need to use another hook, the useEffect hook, which we also need to import from React. The useEffect hook is for side effects, such as DOM manipulation with a third-party library like D3. Now, before we return our JSX, we can say useEffect. The first argument to useEffect is a function, and the second argument to useEffect is an array of dependencies. For now, we'll keep that empty. And in the body of this function, we can access brushRef.current. This should be our group element. Let's log it out to the console and have a look. It looks like it is, in fact, our group element. Now that we have access to this group element, we can wire it up to our D3 brush. All we've done so far is import brushx from D3. We have not yet used it. We can use it inside of our useEffect hook like this. Const brush equals brushx. I believe this needs some setup to get it working. I'm going to consult this example to see what else we need to set up the brush. After constructing the brush instance, this code sets the extent of the brush. This is important because it specifies the interaction surface of the brushable area. The extent setter accepts as input an array of arrays. For brushx, the first of these arrays is the xy coordinates where the brush starts, and the second array is the xy coordinates where the brush extent ends. We can set up our extent in a similar way to this. So I'll copy this code, and then I'll paste it in our example. But instead of using width and height 2, we need to use inner width and inner height. Because this effect references these variables, they are now dependencies, which we should include here in the dependencies array. The effect this has is that each time any of these dependencies change, this effect is executed again. It's good practice in general to include all of the variables that you reference in your array of dependencies for a useEffect hook. Now that we've set up the brush extent, I think we can just invoke brush with our group element, and the interactions should be set up. We've got this error, t.property is not a function. This indicates to me that brush is expecting a D3 selection of this element. To make a selection of this, we can say select and pass in this group element. And at this point, select is not defined. That's because we never did import select from D3. Now we've got our brushing interaction. All right, that's half the battle right there. The remaining steps include listening for when this brush changes, And when that happens, filtering the data that's shown on the map. Let's start by listening for changes in the brush. Every time the brush changes even a little bit, I'd like to recompute the filtering for the map. And I think we can listen for that event by saying brush.on brush. And then for now, I'll just pass a callback function where we can say console.log brushed just to check if it's working. Now, if I brush, all right, it works. It prints out brushed every time the brush moves, or the brush gets created, or the brush gets destroyed. Oh, actually, it doesn't get invoked when the brush gets destroyed. But that's a case we can deal with separately. Now that we know when the brush changed, we need to know where the brush changed. Like, where are these beginning and ending points of the brush? Because that's going to determine our filtering. Again, I'll consult this example. When setting up the brush, a function called brushed is passed as the event listener for both the brush event, which we've done, and the end event. What does this brushed function do? Here's the definition of that brushed function. It's accessing d3.event.selection. I think we need to do the same. To do that, we need to first import event from D3. And then instead of logging out brushed, we can log out event.selection. Now if we brush, we get these two numbers, an array of two numbers. The first number is the starting point of the brush in pixel coordinates. And the second number looks to be the ending position of the brush in the x direction. Now that we've got these numbers in pixel coordinates of the brush beginning and end position, we need to get these back into the domain of our x scale. Because ultimately, we're going to need to filter the points on the map by their date. So the next step is to transform these numbers here into the dates that they represent on this axis, on the x-axis of this date histogram. To do that, we can use xscale.invert. Let's deal with just one of these numbers to start with, namely the first coordinate of our brush extent, which we can access as event.selection at index 0. Now we can call xscale.invert and pass in that number, and now when we brush, we get out dates. The .invert method on scales is the inverse of invoking the scale itself. It accepts as input a value from the range of the scale and returns a value from the scale's domain. In this case, it takes as input a pixel coordinate in the x direction and returns a date. Since event.selection is an array, we can use event_selection.map and then pass as the function to map xscale.invert. This will apply the xscale.invert function to both of these pixel coordinates. So now when we brush, we get this array of two dates. Now we've got what we need to do the filtering of this data. All right, we've got our two dates inside of this callback, which is inside of this useEffect hook. And we want to use these to filter the data that's shown on the map. But that's like way far away in the code. I think that's defined in index.js. It's pretty far removed from this code here. So how do we get from here to there? Well, we can use unidirectional data flow. The way we've been building systems for dealing with interaction with React so far use unidirectional data flow, and this case is no different. After we set up our event listener, that event listener can change state. And then based on that new updated state, the whole app, or the part of the app that needs to, can re-render itself based on that new state. But with this brushing, what is our state? Well, we don't have any yet, but I propose we introduce a piece of state that knows where the brush is. In other words, the brush extent, the begin date and end date for our brush, can be part of our state. Based on that state, we can compute the filtered data that we pass in ultimately to the map. Instead of console.logging this array of 2 dates, I'm going to call a setter function, and I'll call it setBrushExtent. This does not exist yet, but this could be defined in index.js and passed in as a prop to our date histogram component. So I'm going to unpack setBrushExtent as another prop for our date histogram. And then over in our top level index.js, when we invoke our date histogram, we can pass in another prop called setBrushExtent. And the value of that can be a state setter called setBrushExtent, which we need to define. We can define that at the top of our app. I'll say const brushExtent, comma, setBrushExtent equals useState. This is how we can use the useState hook to set up some React state. I'm not sure if we imported that from React, so let's import useState from React. Now, if all is going according to plan, we should be able to console.log brushExtent, and this should update as we brush. Before we do any brushing, we get 3 times undefined. That makes sense because the first time is before any data is loaded, the second time is after one of these data pieces is loaded, and the third time is after all of these pieces of data have been loaded. You got to remember that every time a piece of React state changes, the whole component is invoked again. This is something you got to always watch out for. But anyway, here's the moment of truth. If I brush, all right, it's printing out these different dates. All right, so far so good. All we need to do now is derive the filtered data from the original data and this brushExtent, and then pass that into the map. I'll get rid of this console.log, and then after the check for whether the data is loaded yet, that's where I can put the logic that computes the filtered data. Const filtered data equals, we can use the built-in array method filter on data by saying data.filter and passing a function that takes as input one row, d. And what do we do from here? Well, the function should return true if this row is inside, in between those 2 dates. So first, we need to get the date from that row, and second, we need to compare it to both the begin and ending date from our brushExtent. So first things first, we need to get the date. I believe we had a value accessor called xValue, so if we call xValue of d, that should give us the date. However, that xValue is not defined anywhere here. I believe that's defined inside of date histogram. So maybe the thing to do is to move that definition out of date histogram and into index.js. That way we won't have to define this very dataset specific function in 2 places. We could just define it in one place. We could go all out and refactor all of these to be props, but Yagni, you ain't gonna need it. It's a principle of coding that says only do the refactoring that you need to do to get done whatever it is you're working on. So xValue we can unpack as another prop, and then I'll move this definition of xValue out of date histogram and into our top level index.js. I think I'll just put it right here at the top. And then we need to pass in xValue as a prop to our date histogram. And now we can continue working on this function here. Now we need to compare this date to both of the dates from our brushExtent. To make this more readable, I'll expand this into a proper function body. And I'll say const date equals xValue of d. And then we can return, is that particular date greater than brush extent at index 0. In other words, did that date come after our initial brush point? And is that date less than brush extent at index 1? If both of these checks pass, then this row is within our brushed region. Finally, we can take this filtered data, and instead of data being passed into the bubble map, we can pass in filtered data as the data prop. Let's see, does it work? Cannot read property 0 of undefined. Well, that would make sense if brush extent is undefined, which is what it is initially before we brush. We need to deal with this case of the brush not being defined. In this case, what should be shown on the map? Well, I think in this case it makes sense to show all the data on the map and not even do this filtering. So we can introduce a guard here and say if there is a brush extent, then we do this filtering. Otherwise, we can just set filtered data equal to data. Okay, now it's not broken. And now if we brush, all right, it's filtering the data that's shown on the map. This is pretty cool. Now we can sort of see the evolution of these events over time and where the various hotspots are at different points in time. This is pretty awesome, pretty amazing. There is a bit of a lag when I'm interacting here, and there are a bunch of performance optimizations that we could do to make it faster, but that's a nice first pass at adding brushing with these linked views. To recap how this is all working. In our top level index.js, we've got a new piece of state, the brush extent. This is used to compute the filtered data, which only includes rows whose date falls within that extent. And then that filtered data is passed as the data for the bubble map. When we render our data histogram, the setter for our brush extent state is passed in to that data histogram. Inside of our data histogram, index.js, we're setting up a React ref called brush ref. And I think I'll just move this to be down closer to that logic related to the rest of the brushing stuff. So we're setting up this brush ref, and then when we render this group element that comes at the bottom of everything, putting it above everything else in the Z order, we're passing brush ref in as the ref prop for this group element. Because we're passing in the ref like this, after React renders this group element, the raw DOM element is exposed to us at brushRef.current. By the way, this useEffect hook is invoked only after rendering is complete, and the DOM elements are actually available. Otherwise, brushRef.current, if you put that out here, for example, it would be undefined because we didn't pass anything into useRef. But anyway, in this useEffect hook, we're invoking brushX from D3, and we're setting the extent to go from 0, 0 to inner width and inner height. We are setting up this brush by invoking brush as a function with a D3 selection of that group element. Finally, we're adding an event listener on that brush for when the brush changes, and then we're accessing event.selection, which contains an array of two numbers, the two x pixel coordinates for the beginning and ending point of our brush. And then for those two x pixel coordinates, we're passing those into xscale.invert, which will return dates. So the return value from this expression is an array that contains two dates, and we're passing that to the state setter for our brush extent state. And now that I think of it, I don't think we're dealing with the case where the brush ends. See, if I create this brush and then I click outside of it, the brush will disappear, but the points on the map don't change. They should go back to showing all the points. To handle this case, we need to also listen for the end event on the brush. Now if I brush and then reset the brush, we get an error, cannot read property map of null. That suggests to me that event.selection is null at this time. We can handle this by adding a guard and saying, if event.selection is defined, then use it to compute those dates. Otherwise, just set the state to be null. Now when I brush and then reset the brush, the map goes back to showing all the points. Since event.selection itself is null, instead of this ternary operator construction, we can just say event.selection and event.selection.map. Now if we brush and I reset the brush, the map displays all the points again. What's happening here is, in the case that event.selection is null, this whole expression short circuits and just returns event.selection, which is null, which we end up setting as the brush extent. And that can fit on one line. All right, that's how you can set up multiple views with brushing. That's all for Analyzing Missing Migrants Part 6, Brushing.